Part A, find the total number of different arrangements of the 11 letters in the word caterpillar. The number of different arrangements refers to the number of permutation. In the word caterpillar, we have 2 R's, 2 L's, 2 A's, 1 C, 1 T, 1 E, 1 P, and 1 I. There are 11 letters all together. So the R's are repeated, we divide by 2 factorial, similarly for L and A. Therefore, we have 11 factorial over 2 factorial, 2 factorial, and 2 factorial. And that is what we get for part A. For part B, to find the total number of different arrangements, so again, it is a permutation where there is an R at the beginning and an R at the end, and the 2 A's are not together. So let's consider this case. We have an R at the beginning and an R at the end. So this is what we have. And the 2 A's are not together. It is easier to use the complement rule. So we find the case where you have an R at the beginning and the end. The A's are together. When we subtract, we will get the number of arrangement where we have an R at the beginning and an R at the end, and the A's are not together. So for this case here, an R at the beginning and an R at the end, there's only one way to make this arrangement. From 11, we have 9 letters else to arrange. So the R's are gone. The repeated letters are L and A. We divide by 2 factorial and 2 factorial. That gives us 90,720. Now for this case, the A's must be together. So if the A's are together, we hold this as an object. So the R's are gone. That means we have 2, 3, 4, 5, 6, 7, 8. There are 8 letters to permute. And then we need to divide by 2 factorial because the L's are repeated, but this is considered one object. Then we have 20,160. The number of permutations where you have an R at the beginning and an R at the end, and the A's are not together, can be found by subtracting these two. We have 90,720 minus 20,160. That gives us 70,560. Part C, find the total number of different selections of 6 letters from the 11 letters. This is a combination question. It must contain both R's. So order is not important here. It must contain both R's. So we have 2 R, at least 1 A, and at least 1 L. So the 2 R's must be present, at least 1 A and at least 1 L. We must have an A and an L. So these are 4 letters already, but we need to select 6. So we need to select 2 more. If we already have 4 here, then the number of letters that we could select from is 7. So we have 7 left. And from 7, we just need to select 2 more, regardless of what it is. And that gives us 21.